All right, should be live. Let me get my volume adjusted. It's not too ridiculous. So it's been a while. Been busy with a lot of not reverse engineering hardware. But I have a shiny new Mac Pro here. It's actually been here for a few days, but had some other stuff to take care of first. You may have known that we just announced the Asahi Fedora remix last week, so that had me a bit busy then, but here we are. There's a Mac Pro next to me. It's actually huge. Like, I didn't realize how big these things were. It's bigger than my Threadripper, which is kind of ridiculous. And we're going to see how far we get with Asahi Linux support today. So I'm going to tell you what isn't going to work, which is video output from the onboard outputs, because that depends on stuff that Sven and Jen now are working on. And yeah, that's not going to work. That's not the plan, though. However, what I have done is I stuck a Radeon in there, a very, very cheap Radeon, which is what I had lying around, and also because I have no idea if you can even get like auxiliary power in these things. Like, there's a connector that I think is intended for like serial ATA hard drives, so I don't know if you can pull 12 volts from that and whether it's enough for like a decent GPU. So I have a really crappy GPU that makes no sense, but it's a GPU. So yeah, if we get anywhere near that far, we're going to find out whether that has any chance in hell of working or not. So that's in there in one slot. The other slots are populated with the default, the IO card thing they have on the top one. And I just updated macOS on it. And there are plugs inside for PCIe power. Okay, so then I guess that, yeah. I mean, you're going to need some adapter, though, for the usual GPU stuff, I guess. I get some water. Either way, this card doesn't need any power, so that's fine. The open source drivers will work on all platforms, hopefully. So yeah, another thing we're going to be trying is trying out is the central scrutinizer. Actually, let me just check that, make sure this is all reasonable, and I'll show you. I think we're good. Yeah, let's switch to the screen. So yeah, I have been using a horrible like Arduino hack thing that I've had since the very beginning of the project mostly for rebooting machines, but also for serial port. And Maz, the KVM ARM64 maintainer, made a production version of that. It's called the Central Scrutinizer, and remember I said early on that I wanted to make like a debug type C interface thing that could do like everything. This is not that. This isn't nearly as fancy as that, but it does give you serial and reboot control and stuff on Macs, which is what you usually want anyway. Dev machine is still the Intel. Mostly waiting on the video output so I can switch to that to Asahi full time. But like all my laptops are Asahi now. Like I haven't touched my ThinkPad in like a year. So like the mobile machines I take everywhere are all running Asahi and stuff. It's just my like workstation still is an Intel. So yeah, here's the central scrutinizer, and it pretty much is. I'm just going to use it for reboot and maybe serial if I can get Mini to work right out of the box. So the first thing we're going to do is going to go into Mini and see how much is missing for the M2 Ultra, because I know like we usually. I think this is already up to date. Yeah, on 3.2. Yeah, Lena was working on the M2 and the 13.5 firmware support. So that's actually, I think that's already packaged for Fedora. So that was most of the work that was going on there recently. And there was a few screw ups at the end, so we ended up with 2 extra versions. But now it's my turn, and I'm going to be working on the M2 Ultra. I don't expect anything weird because we support the M2 Max. It's not released yet, but like all the support is there. It's almost ready. And we know how the M1 Ultra works, so the M2 Ultra should be the same thing. You know, it's like a matrix, right? And we have both dimensions, so it should just work. We still need to make sure we add support for it, though. Well, you work on the video output, so you can switch, or is that not your area of expertise? If I run out of other stuff to do and it looks like the other folks need help, I will give them a hand. But for now, I'm just going to let them work on that because I think they're doing a pretty good job. So, yes, this is the device tree that is not what we're looking at first. First, we need to look at Mini because we need a Mini that can install and run on these things. So all I'm going to do actually is just... do we have any of that? No, we don't have any support for M2 Ultra, but that's easy enough because then we just copy it and paste and make this T6002 and make this T6022. Because obviously the Ultra is two of the Max, so everything is the same as the Max, just with more stuff. So that is sock. Chickens is going to need a little bit of silliness. Where is that? Where's the T check? Here, wait. Oh, no, okay. Those are the part numbers. Those should be the same for Ultra. The GPU stuff, I don't even know if that's going to work, but I mean, we're just going to add it in. Where's anything else? Yeah. We're gonna need the N clusters. Oh no, the fuses here are the same with the offset. Okay, so that might actually just work. The problem is then we need... Yeah, okay. Yeah, I don't know how half of this works. Lena's gonna have to do the GPU bring up. I'm just gonna like bullshit it. And like Lena can figure out if this makes any sense. But for now, at least these offsets should be fine. And it's just adding 4 to that. Probably not to that though. I'm guessing. I have no idea what. Those are an array of what? Max dies. Okay, yeah, I'm assuming it's +1. Anyway, yeah, the GPU really doesn't matter right now. So let's just go for that. Put a fall through comment in there. This is just like preliminary. Okay, CPU frequency. That should be easy. So we just make this D6022. And then 21. Same as 22. And then same thing here with the features. I don't even know why we didn't do this earlier because, I mean, we could have just preemptively done this before the release anyway. Okay, so we have that. And I missed one in GPU, I think. Yes. Yeah, that looks right. And SMP. And then also in SMP is the max number of CPUs, right? Is that right? 24? Yeah, it's 24 on these, isn't it? 12, yeah, 24. I think I did set that higher on purpose early because I expected that when the M2 came out. The feature map already contains some supported M2 Ultra things. You mean like on the website? Like, I mean, those are just assumptions, right? Because again, the Ultra is just 2 times M2 Max, so you can just assume that all that stuff is going to work once you have a device tree for it. Like, the Linux should need 0 changes for this, other than whatever GPU things Lena needs to do, because that always needs some tweaks and stuff. But sorry, I lied. Except for PCIe, because PCIe is a bit special on this one. So we don't know how. Yeah, somehow the M2 Max looks like it might have 2 PCIe controllers, because the addresses are different on the Ultra and the Max, at least on the Mac Pro Ultra. I haven't looked at the Ultra for the Mac Studio. That one might be the same. But at least the Ultra on the Mac Pro is different from like the Macs on laptops. So it looks like they have two PCIe controllers, at least at the logic level, and somehow like they choose between them. Although they use the same physical hardware ports because like they don't have extra ones of those. So that may or may not need changes on Linux, depending on whether it's compatible with the other one. Well, the Asahi distro die, it will be in maintenance mode, I guess. Like we'll keep updating the packages, but don't expect a lot of integration work to go into it in the future because it was kind of a demo in that sense. The plasma image will die. The minimal image will stay. And if other people want to contribute and add extra fancy stuff to it, that in the future that would be great. But like existing users are still going to get updates at least of the kernel and the usual packages. And the really obvious stuff that we are developing also for user space. I'll make sure we get the most important stuff packaged, but don't expect like the polished kind of integration. Okay, so that should work. We have to purge the partition and install any Fedora. Yeah, if you want Fedora, yes. Okay, so that I'm just gonna go and boot that and see what happens. I expect it to run, honestly. There's gonna be no video output, and I need to disable the video output so it doesn't explode. Actually, this is kind of dumb. Let's fix that. I remember this. So right now it has this hack where we are skipping in it on non-supported blah blah blah. What I actually want is we can just check for external displays. So if display is external, actually it'd be good to get the device tree out. Well, anyway, if the display crashes, it doesn't matter. It's just the work. So then what we do is if display is external and then we check for like M2 plus. And the way we do that is by looking at the sock stuff. Same thing we did in check-ins and all that. In CPU freak will work. Chip ID. Because this way we automatically disable the Run 2, 60, 20, 22, skipping display need break, switch. And I need sock on this. So that should be a little bit more future-proof. It doesn't really matter. What's the ETA for this project? You mean like the Mac Pro bringup? I mean, it might be done today. It's on whether I run into any weirdness or not. 3 dots for that. Let's call that M2 plus desktop. M2 plus platform. We don't need the model node anymore. What IDE is that? This is Kate, just the Katie text editor. Source sock. Okay, so I commit on that display. I came to plus desktop disable hack more generic. famous last words because I might find that this display as external thing is kind of bork. Actually, I have no idea how the display works on this one because like there's going to be multiple display controllers now that are used, and I mean there's two HDMI ports. I would expect them to be connected to the two. Because there's 8 Thunderbolt ports, which is all of them. So the two HDMI ports have to be connected to the two display controllers, which explains why they renamed them to like DCP0 because that's DCP1 showing up now, and DISP1 should be in there. We only look at DISP0, which is another reason why this is, not going to work as intended. But they should all be marked as external. So I would expect this to work anyway. Hey, Drew. Okay, so for those who know, Drew sponsored this Mac Pro. So nice to see you here. Thank you for that. Okay, yeah, let's just make sure this is all built and build server 5000. Oh, yes. That. Okay. And now we go on the Mac. I also noticed that it doesn't let you turn the thing on if the case isn't like in and locked, which is like really pedantic. Why are you not doing that right? Okay, here it is. So I did just update this, so it should be fine. We're just gonna go straight and actually, should we install Asahi first? Get an actual OS there? Yeah, actually, you know what? Let's do that. And the reason I want to do that, I think the dev installer should let... Do we have things on the installer yet? That's a good question. I know we have the... I know we have all the other machines. Do we have the Mac Pro? Yes, J180 DAP, that's the Mac Pro. That should be 12.5, the firmware we offer. Okay, yes. So yeah, let's do an install, which is not going to work. Actually, Fedora should work. Let me remind myself about the devil. Is that the address? Yes. Is it devil? Dev. That should work for us, and I think the latest packages. I think this should work. Oh, it doesn't have the telemetry. I wanted to show you the telemetry stuff. Yeah, because that's in the Bootstrap script. Okay, let me just. Actually, I can just export it here, so it should work if I do it like that. So I did actually implement the telemetry thing I mentioned on Fedi. So I want that one, and I'm going to call that... Wait, that's not there? Oh, sorry, I need the Bootstrap dev. So let me get the console in here. That is Japanese. That's still Japanese. Why is my... Oh, no. Why is the input method sticking to Kana and not listening to the switching keys? Terminal. It's Fedora. Okay, so we're going to... You can't really read it because it's tiny, but give me a second. I'm just going to put the environment variables in there. So the telemetry actually works. Hopefully I didn't typo that. And then I need... Okay, this should work. I think I didn't botch that. Zero 6 1, yeah, that's right. Yes, I do want expert mode. That didn't like it. J180 DAP. Did we typo something in the installer? I get the feeling something's wrong here. No, it is here. J180 DAP. Why is it saying the device is not supported yet? Should be in expert mode. Did I mess something up? This Chipman verb. Oh, we forgot that. That's what we forgot. Oops. Might as well tag and release it then, I guess. I mean, this is on dev anyway. Let's just git push, so I can see how I release the installers. I did not mess that up, did I? No, it should be fine. Let's build dev. Push dev. Oh, actually, no, actually, hold on. Releases dev. I'm going to delete that and do it again because I'm going to bump mini, because we're going to need the new menu for that and it's not tagged yet. No, that's fine. We'll do that later because I need to replace mini in macOS anyway. So, and I can use the one I just built for that. And we'll do another installer release, of course, before this is anywhere near production ready anyway. So that's fine. This is going to install a broken mini, but that's okay because we're going to install our own mini anyway. I don't know. We're going to find out. There, 062. Yes, expert mode. Okay, now it works. And resize an existing partition. I don't know, 3 terabytes for macOS for now. Partition 1. Interesting. So I think this overhead stuff is showing up recently. I might just need to increase the, like maybe this is normal. I might just need to increase the default like calculation so it doesn't throw that warning. Because I see a bunch of people reporting that. So yeah, let's get 3 terabytes to macOS. I mean, it might be completely. Well, okay, no. So we know we can make PCIe GPUs work with a horrible kernel patch. The thing is, that's a horrible kernel patch. That is, and has terrible performance implications. The real question is, can we make them work without that? And I have no idea if Apple fixed that in the new machine. So we're gonna find out. Okay, let's install that. Let's get the latest KDE Plasma image. And we'll give this 80 gigabytes should be enough for now. Fedora Linux with KDE Plasma. Yes, 13.5. It's standalone. I don't have a server rack at home. Mostly because all my servers at home are Macs now, except for my old Intel one, and a rack doesn't make a whole lot of sense for Macs. That download is faster than usual. Oh yeah, this is on 10 gigabit Ethernet now, I think. It might not be. This cable might be plugged into a 1 gig port. But yeah. I also improved the installer, so it should download faster now anyway. Funny, I just realized the macOS base system showed up on the top right. That was the recovery image getting mounted and unmounted. That's kind of fun. Fedora is started out faster, but now it's stalling. Okay, that was a bit. Yeah. Okay, so the CDN for Fedora is a bit funny, I think, with partial downloads, which is what this does, and sometimes it caches them, sometimes it doesn't. So, yeah. I am installing Fedora now. Okay, yeah. So this is going to take a while. I still have a mix of Arch and Fedora machines, but like my main build machine is now Fedora based with the Arch stuff in a CH root. And I'm going to be slowly transitioning most of my stuff to Fedora. My servers are all Fedora already since before the announcement. Okay, the very first one I installed, I had some really messed up kernels that I had to use, but now all that stuff works fine because it's an M2. The main thing with the M2's desktops, like the Mac Minis, is the display out. Everything else works right now. So we're just waiting on that for releasing that. Is it possible to boot Linux on Macs? Nope. You need to install at least part of it. Macs do not actually support live booting anything. It's always boots from internal storage. Yeah, it's going to take a while, I guess. Maybe we should look at the device tree a bit while that runs. Okay, put the keyboard away. And let's look at this device tree stuff. So, Linux, Arch, ARM64, boot, DTS, Apple. So we have T620, 621. So we already have everything broken up for multi-die. We're basically just going to copy the M1 Pro to the M2 Pro, and then we're going to copy the M1 Ultra, sorry, the M1 Ultra to the M2 Ultra, and then the M1 Ultra Mac Studio to the Mac Pro, and that's going to be very different, but we're going to see what happens. Edit everything for 22. Everything for everything, actually. Yeah, the Fedora installers are really slow from Japan. I think it's on CloudFront now, but like the Bunny CDN that we use for Asahi is apparently better than CloudFront, so I don't know. So T6022 DTSI. And so this is T22 M2 Ultra. Do we have the code name for that? Rhodes, yeah. So it would be Rhodes. Oh, that's wrong. It should be Rhodes. J was the M1. H14J, is that right? Yeah, I think so. And then this would be Rhodes on C, assuming they have the same naming scheme as before, because I think it was that for M2. Oh, it's just Jade, and then we called J2C. Okay, yeah. So let's just call it Rhodes then. Let's do CN22. And then 21, I think. Yeah, M2 Max. H14J, and this would be H14. Still J for 2C, I think. Okay, and then 2x common. This is just 2x, and we're pretty. Oh yeah, so the E cluster on this one is going to have 2 more cores. 11, 12, and 13. So just copy and paste these. 2 and 3. 802 and 803. Everything else should be the same. The capacities, we'll see about that later. And these would not be Ice Storm and Firestorm. What do we have on the original one? On the T6001 and 20 die, what was that? Die 0 or common. Where's the CPUs? T6, T20. Is this in T6002? 1? Where's the CPUs? Common? A common, okay. Yeah, so what we have here is Blizzard OPP, yeah. So we're just going to copy and paste this, actually. It's E13, E12, and this would be 802, 801, 803. I think. Yes, 898. Yeah, that makes sense. So yes, these are Blizzard. We have some capacities there. That's good. Make sure these are all lined up. I think so. Yep, 803. And then I also need to copy the others. Avalanche. Those should be actually the... Oh, wait. Is that right? The... Oh, yeah, no, they should be. Yeah. That's 9 then. Yeah, that is right. Just going to copy and paste those. So that'd be A03, 10, A03, A02, A02, A01, A01, and this would be A00, A00, and 903, 903, 902, 902, 901, 901, and 900. So that should not be lined up with pinged on IRC. Okay. 58 viewers. Wow. Okay. I guess a lot of people are interested in the Mac Pro. So P0, be a freak P1. Yep, that should be right. And the caches should be fine. I don't know if the numbers are right for this. I'm assuming these are that. I don't know if this one's right. Should be, though, if that's the same as that. And then die 0, simple bus. Just gonna guess this stuff is okay. And die 1 on yeah. We'll see about it. P manager is gonna need probably some changes, but maybe not that much. And then this is going to need the extra eCPUs in there. Um, 6022. This would be G14. Was that different? I think that was supposed to be different for... I think it was supposed to be G14D or something like that. Actually, I guess C14X because it's using the T6022 anyway. Shouldn't L3 also be defined? Kind of, but we don't actually interact with the L3 much. I don't know. There is the system level cache. I don't know if that counts as L3 as far as Linux is concerned. But I don't think it matters too much. I do expect the kernel to boot other than the... I mean, guess it's the same chip. It's like the M2 Max. It's just they took two to glue them together, right? We already have the multi-die stuff worked out, so it should just work, except for the PCIe question mark. So that 2x. Yeah, that's... That should be okay. Okay, hopefully this finished by now. Yes. So you get to see the new telemetry stuff now after that finishes. Yeah, there you go. So there's the telemetry stuff. And you can press D, and it actually shows you all the data it's going to send with comments. So hopefully this keeps, you know, the privacy people happy. And then you just send it. So, enter to continue. And now it's going to do the usual thing with the reboot. Is that actually working? I think so. Yes. Okay. Okay. So that should get us into recovery mode now. Okay, there we go. And that will get us into stage 2. But again, this is definitely not going to work. Because that mini doesn't even have support for this sock. So this is kind of BS at this point. I could just leave it without doing this, but I guess we might as well do it. And again, this is kind of completely pointless, but we're going to do it anyway. And then we're going to reboot into a lovely black screen because I guarantee none of that is going to work. And I don't even know if Fedora is going to be happy with that kind of abuse. So we're actually going to just turn it off. We're going to go back into macOS and then first switch to that, then do a force power off and install Mini here because we're going to have to do some reverse engineering experiments. So we need to put Mini in place of macOS. And then we'll see about talking to Mini. Okay, so shut down. So I just installed Fedora just to get the root file system in there, but it's, as I said, definitely not going to boot yet. Oh, hey, Gratham. So back to recovery mode, but this time on the macOS partition. And now is when I get to do the HTTP server, which is ready. Let's make sure again that it's compiled. Okay. So, options. That is slower than usual. Okay. Utilities, terminal. First display everything. We're going to have two boot policies. The Fedora one we just installed, and the not paired is the Fedora one. The paired one is macOS. That one is let's start with 6.8. So we disable everything on the first one. No security. And then needs that. Always forget the arguments to that. Mini bin, volumes, Macintosh HD, raw, last virtual address, 0 entry point. 2048. This isn't even built for serial port early debug, but I'm kind of expecting this to work anyway. So let's see what happens. So this console, if it works, will give me the mini secondary terminal. That's just for rebooting, but some serial should pop up there if we get there. So we're just going to reboot and see if we get anything. No video, of course, because as I said, that's not going to work. I see a reboot happening there. Oh, yes, we got mini. Okay, yeah, so USB works. Excellent. No serial. I forget if we just disable that when not built in that mode, but anyway, doesn't matter. But we have ourselves a mini shell. Woo, okay, that. Okay, so it doesn't like, some GPU stuff in the device tree, but yes, M2 Max Blizzard is the CPU because it's the same as Max. That's all as expected. Mac 14JJ180D, chip ID 2022, firmware 13.5. A ton of mappings. We're going to need some of these for Linux. What the heck is that? Well, that's fun. That doesn't look right. Oh, no. Those are probably carve-outs. If so, that's fine. And then these are the second die. Okay, no, that's fine then, yeah. These are RAM carve-outs. That's fine. A C2 with 2 of 8 dies. Excellent. Disp 0, no, not found. Okay, I didn't even find the display stuff, so that was kind of useless. That's just because there's no actual payload, and then that's just the ACP stuff that gets confused there. That's the fake dummy initial frame buffer we get, which is a lie. We do get these 7 Thunderbolt ports. And then Mini hates the AFR perf state stuff. So that is going to be fixing stuff here. What happened there? AFR perf states. Probably because there's more than one set. So that came from GPU perf state 64, which is a base count state. So, okay, there's going to be something funny there, I'm sure. Oh, is that the die count? Maybe that's what that is. It was called base before, and I think it's not base. Because like 2 just screams die count. And then it has 7 perf state. Oh, and are they just lined up in sequence? Kind of looks like it. Okay, I think I know what happened there then, yeah. Yeah, okay, so what we need then is dies. Is it this? Am I getting this right here? I think you used this like that. Yes. This dies. So there's 2. That looks like the min-SRAM volt thing. And then here, instead of greedy range, I guess it's an array of arrays. Dies array. Discount. Birth state 64. Let's try that. Hey, that works. mini.adt-read mini.bin mini, not me, what am I doing? Let's call this the Mac Pro adt.bin. Okay. Hey, thank you for the super chat, Mitsaka Jiang. Again, I'm not promising that today, but we'll see. Okay, so this all looks very normal. Let's just see if that perf state stuff made sense. Yeah, okay, so those are normal. Then the AFR perf state, I still count 7. Yeah, 7. Yep, that looks right. And then 2 min-SRAM volts. Yeah, that looks right. So I guess the GPU stuff is going to need some fixes for that from Lena to actually run, but for now, let's just commit that. Okay. So we have ourselves a mini. Now, the next thing that we're going to need to do is look at that PCIe mess. So if we look search for PCIe, there is a PCIe switch, and I have no idea if that needs any initialization or not. That's going to be interesting. And then there's this PCIe G0 stuff. And if we go into the device tree and look at T6022X die X and look at PCIe, it's not there. Oh, because we only declared PCIe on die 0, which is fine, because die 1 was never used on the older Mac Ultras. However, the trick here is that we're going to have to disable this in that variant, at least in the Mac Pro. I don't know if it's what's up with the Mac Studio yet, but for now we're going to just disable that in the Mac profile, which is going to need a bunch of changes anyway. And we also have extra, okay, so this is Mac Pro M2 Ultra 2023, this is T6022, 1ATD, ARM platform, 6022, 2XJ. Right, we don't need that. There's only one Mac Pro. So 375 is where? this Mac Pro into Ultra 2023 J180D. And we don't really get to include that. We're just going to merge everything into one because I'm not sure if the Mac Pro and the Mac Studio are going to share that much with all the real like funky stuff going on in the Mac Pro. We definitely need, we're definitely going to have 2 extra ports there. We'll have to figure out this USB Type-C stuff. Probably not a big deal. And then we're going to need all this stuff in here. I don't know if this DCP stuff is going to work. Ethernet, we'd have 2 of those. So then, copy that in here. And then all that stuff. Serial, DCP. Okay, so I'm just going to call that HDMI A for now. I don't know if, I mean, yeah, it's going to be one of the HDMIs. We need to get those Type-C things in there. So we have 8 of them. So we can just put those in here. And so those would be 6 and 7 for the front. And then we get 2 extra ones. And we need to figure out the 4 and 5. And then let's get the addresses from the device tree. So let's do that now. HPM is the magic word for that. Bus manager 2, 3. Why is it like 2, 3, 4, 5, 6, 7? Where's 1? Where's 0 and 1? Oh, different. It's on a different I2C port, isn't it? Okay, back, right, back, second from. Okay, I love the naming there. Third from right, fourth from left, second from right. Okay, so it's in 2 separate I2C controllers. So this is an I2C 0, which is fine. So actually, we have the rear. Well, we're going to use the same naming as Apple then. And HPMs, because it's a bit easier if we keep it the same as Apple. So HPM2 is address 59, which is 3B. That's correct. I don't know what they call it 2 anyway, but we're gonna stick with those names. Actually, we need to figure out if they line up with the Type-C ports in the same way. Yeah, so APCIe C2 is, yeah, so it looks like the ports do line up like that, and ACIO 2. So we're going to keep those numbers. So 3B, and then we have 59, 60, 57, and 58. Okay, so 3B, 3C, and then we have 57, so 39, and 3A. And then we have 61 and 62. So 3D and 3E. Okay. So then we need to make sure these are the same there. 3B, 3C, 39, 3A, 3D, 3E. And then the interrupts is the only other interesting thing. Those are going to be part of the ping control. And the numbers should be the same. I think there's only one interrupt, actually. Yeah, it's just GPIO 0. So that's as expected. And that means the GPIO is 44. And I think it's the same for all of them. Yeah. And then these should be right. Type C 2, 3, and then we call these 4, 4, 5. But no, some of them are going to be in the second die. And then we want to use the die 1 naming. So we're going to do 2 and 3. And then for this, how do we do that in, yeah, it should be the same here, actually. 375. Where's that? T6002. Am I missing something here? That one, yes. 375D. And then we have C4. Type C4. Oh, it is called Type C4. Oh, because these are here. Okay, yeah. But these are then defined in die 1. Yes. Okay, that's fine then. Type C2, Type C3, Type C4, Type C5, Type C6, C5, 7 also. And USB-C rear 5, rear 6, I guess. 5. Let's call it back, I guess, instead of rear, because I'm calling him back. Back 4. Back 3. Back 2. And back 1. And that would be Type C2, Type C3, Type C4, Type C5, Type C6, Type C7. I think that's right. Yeah. All of them on IRQ44. And then the HPM, so IS2C1 has a speaker. I'm just going to ignore the speaker for now, maybe. No, I mean, we can declare it. It's that isn't thing. Okay, hold on. Okay, so IS2C3 is the one that has the extra ones. HPM 0, and so HPM 0 here is on address 56, 38, and then this one's going to be on the usual 163. 3F. Yep. And it's Type C0 and Type C1, and these would be front left and front right, I assume. Top right and top. Okay, so it's right and left. Top right and top left. And the interrupts here are 60. And the endpoints look fine. I think that should work. I might need I2C3 to be enabled. Is that even listed in the die yet? It is here, and it is disabled. So I need to say enabled. Status equals, what is that called? 180. Where's 180? Where's 180? Here. Where? No, not what I want to go. 180. Status okay. That's what I want. Okay. And then we do actually use all the controllers on die 1 and on die 0. Were those declared on D7X75 USB controllers? Yeah, so we need all this stuff. And Type C5. So we need everything. Okay. But then those are declared as C0 die 1, Type C4, Type C5. And we need 2 more, because we actually have all of them now. type C6, and type C7. Two and 3 in die 1. And then the phi's, same story here. Die 1, 2 and 3, die 1, 4, 5, 6, and 7. 7, 6, 5, 4, 3, 2, 1, 0, 7, 6, 5, 4, 3, 2, 1, 0. Yeah, that looks right. And in this case, they are not unused, so we don't delete those. And also not those. This 0, I don't know how that works yet. I guess we might as well delete them, but we'll see about that. And audio is probably the same as the Mac Studios. Speaker on 1, yeah. Codec on 2. I'll have to look at that clock reference, but... And also this is disabled anyway, but yeah, we can just copy and paste this. So the addresses are probably the same. I think the Apple never changed this stuff. Where is that? Isn't that a typo? It should be address cells with 2 L's. Come on, Apple. That just proves that they don't use that property. They're all typoed. Wait. Oh yeah, they are all the I2Cs typoed? Okay. Great. I never noticed that. We're gonna need to change the interrupts at least. Oh no, you don't set those. So we need the shutdown GPIO though. Oh, and there's a woofer. Ooh, they have a woofer. That's why it sounds so boomy. Well, I guess they would put a woofer in the Mac Pro, even though it's a speaker built into the machine. Yeah, okay. So... Anyway, this is all going to be disabled, but... Speaker woofer. So what are the... Oh, yeah, and the speaker one is 7. Yeah, that's the other thing, is they do this stupid thing where the address is in the wrong one. Okay, that's 46, I guess. Or is it reg? No, it's reg, sorry. It's 38 and 39. Yeah, okay, 39. 39. And the shutdown GPIOs... I guess that's reset. But it's not in pin control now. This is in SMC now. But there's external power provider. What is that? What is that? That doesn't look right. Oh, MCA, okay. Audio speaker. Let me look at another device tree to see if it was also named like that. ADT M2 Air, for example. Speaker. So that has... No, that's also on SMC. Wait, isn't... Oh, no, that isn't. Sorry. Oh, no, that is just GPI. I'm confusing myself because it's just as a call, but it's still... Okay, yeah. So function reset is 260. And that is GPIO 0, yes. And so on the M2 Air, that speaker is 58. Does that line up? 88 on that one. The M2 Air would be 8112J 413 DTS speaker. Okay, it shut down GPIO says 88. Okay, so it is that. It is the function reset, what they call it. Speaker. So then we have 39, which is 57. And I think it's the same for both speakers. Yeah. Let's call sound name prefix. Let's put that on there. Tweeter and woofer. And this isn't even enabled right now, but might as well put it in. I'm pretty sure the jack is going to be the same as usual. And then in sound here, we need both MCAs. Do we? Maybe not. Because this one has 4 speakers. How does it map one to the other? Pro J180, Mac audio. Speakers. Disabled CPU, speaker tweeter, speaker woofer. Yeah, I don't know how those things are mapped. Okay, so obviously no backlight, no MTP, because that's the touchpad, so that's all gone. No PWM, I2C4, I don't know what's on there. So wait, how are the MCAs assigned to the speaker? Okay, so this is putting a loop back on MCA1 and then the codec on MCA2. So I think MCA0 is all we need. I don't know how this maps on Linux, though. So J313 only has 2 speakers. And we still have those on 2 MCAs here. Yeah, I don't really understand how the mapping works. Anyway, the codec is going to need at least the reset GPIO checked. 8. And it's on 262, which is probably right, the nub one. And interrupt is 59. And 4B is the right register. No, the MCAs have, like, you can have multiple codecs on them, but like there's 2 lines, and usually on the laptops it's split left and right. But now I don't understand how the Linux driver figures out the mapping if this doesn't say how many per MCA. All this audio stuff always confuses me. Anyway, it's disabled. This is just for completeness purposes. Okay, so the HPMs I think are all fine now. Top left, top right. CMIA, serial, we'll see about all the other stuff. Memory is whatever. Frame buffer isn't going to work. Ethernet. Yeah, so now the Ethernet stuff is where? We do need the boards. Where is that defined? On 375. Yeah, so all this stuff. We still have more stuff here. So in 375, is that right? Yeah. So after audio, and after audio here, we have PCIe devices. And this is going to be fun because there's a switch in the middle, and I have no idea what's going to go on here. So yeah. PCIe port 0. I know Apple, yeah. So that's not going to work because these PCIe ports aren't even there. Which also means all this Wi-Fi Ethernet stuff isn't going to work. So we're just going to leave it commented out for now, and Bluetooth. And yeah, it's basically a single PCIe port and then a giant switch behind it. And I don't even know how we represent the Wi-Fi stuff in that model, but we don't actually need these. Yeah, so we're going to disable the PCIe stuff for now. And in fact, we need to disable the ports. And those are, yeah, so that's here, APCIe. So we disable all the darts. Disable the PCIe 0, dart 0, status disabled. And then this whole PCIe 0 is disabled. Oh, maybe it's just exactly 2 lines, 2 slots per MCA, and that's how it lines up. Maybe that's how it works. Yeah. Okay. So we're just going to disable PCIe entirely. And the Dart only 0 needs to be disabled. Okay. So, are we just going to go ahead and try to boot Linux? I think we are. And this is going to be another annoying recompile, isn't it? Oh, I need to add this to the make file here. At least I think it's mostly C cached. Let me just recompile that. CPU performance domains on die 1 needs a die 1 sub. Okay, now I was compiling about that. Hold on. Performance domains on die 1. Where on T62.2? Where is that? Oh, here. These. Right. Let me just double check against T60.02. Yes, you're right. Thank you. Oh, not here, sorry. Wait. Yes, here. I messed up the IDs also. P10. P11. 13, 12. P1. And also the L2 cache is 3, 4, yeah, so those also need to be incremented. So this will be L2 cache 3, 3, 3, 3, 4, 4, 4, 4, 5, 5, 5, and 5. Well, the early Ultra MDTS includes singles M2. Which one? It's just this one. There's nothing else. Oh, it's P20. Oh, you're right. Yeah. P10, P20. 20, 20, 20, 30, 30, 30, and 30. Okay. Unable to parse input J syntax error at 450 on common. I bet it's a missing semicolon. I always do that. Wait, I didn't even... What? I didn't even touch that. Hold on, what? $450 on 2x common? How? Oh, it's the GPU die repeat. Yeah, okay, there's... I need that. Yeah, that's new. Okay, that's why. This. Syntax error at 545. I bet that one is a missing thing. Yep, missing semicolon, told ya. Almost. Duplicate label, type C2. Aha, I missed 4. And 5, 6, and 7. Woo! Non-existent element PS diff 0 CPU 0. Do we not have that? P manager. That's T103. T6 2X. We do have that. Oh, did I? Where am I? I think I did something silly with the die stuff here. Also, is NVMe even on die 1 on these? Actually, yes. Hey, Conan. Also missing the UAT stuff, apparently. Those are where? Okay, this is T6021. Oh, that's because this one includes 6000X common. No. Common. Why is that not in common? Oh, because it's directly on T6021. We should move that to common. T62X common. Okay, so that fixes that. And now just the PS stuff. Why is PS this 0, CPU 0? Do have that. It is dynode. There's no like if def here or anything. Oh, is it because I deleted that? Oh, no, but I'm deleting die 1 though. Ah. I'm confused. Why specifically this 0? And it's not these. Oh. Where is it? Why? I'm deleting die 1, not die 0. Why? Huh? Is there something wrong about the P manager here for multi-die? Ah, it's missing that. That's why. Okay, P-Manager graphics die 1, yeah, because that one is different. Probably 22. Graphics die 1. Oh, because no, that one is actually only the first die, probably. I'm guessing. Okay, so I just need an if die 0 or something here. Yeah. Syntax error. What now? And. Okay, and now it's complaining about AFR die 1 because, yeah, we don't know if that is correct or not. Lena's going to look at the GPU anyway. GPU is not going to come up on this kernel. AFR die 1, where did that come from? 323 and P manager. No. Oh, PSAFR came from graphics. Now, okay, now I have no idea how. Hold on. Ooh, that is not liking those loads, but I don't care. I'm looking for these. So we have AFR. Ooh, and there's a die to die. Graphics has a parent on AFR. Okay, let me just shell just see if these exist on die 1. So this is die 0. Die 1, it does exist on die 1. Okay, so AFR and the PS graphics does exist on die 1. Does graphics exist on die 1? AFR does at least. There's GPX. GPX on die 0. Yes, it does. Okay, so that graphic stuff does go multi-die. What about graphics? Yeah, it looks like it's on both. If I turn it on die 1, if I turn it on, if I read die 0, it's off. Turn it on die 0. Yeah, it's on both. So that does mean the P manager die stuff needs to go on both dies. And that means we move that from T62X die 0 MISC and graphics. We move that from die 0 to common. Die X, sorry. And we want to sort that by address, so that goes on the 4000s. Which means here. I call that T6021 P manager instead of 6020 P manager. I don't know. Probably shouldn't be that. Yeah, there shouldn't be any 6021s. Yeah. Okay, and then that means, just guessing here, the AFR stuff, 6022, 62X, die 0, comment. Get the comment on that. So this would be 62.202. Copy the. Okay, so it's supposed to be separate. Die 1. Compile. Okay, now we have device trees. And I guess we add a whole bunch of stuff. That's not a fix-up. So we add 6021, no, 61, add 6022. DTS Apple, add. Is that the right format for the device trees? Let's forget that. Yes, no. Yes, DTS Apple GD102. I don't know if that's going to work. We're going to try it. Okay, we got a kernel anyway. Yes. I don't care about that. And that. Okay, let's do that again just to make sure. Will it boot? I kind of expect it to boot. It's... I mean, there's no PCI Express, which is the fun part. Yes. My Threadripper is down, which is why this is complaining about this CC now. Because I literally switched the cables over to the Mac Pro. Okay, so guest kernel. This is probably, I bet something is broken here. But we are just gonna go for it. I think P6 is what Fedora uses for root. I have no idea if this kernel is even gonna be okay with Fedora, but I guess we're gonna try. Try out the console from that. Yeah. Oh, that's not a good start. Oh, the CPU secondaries didn't start. That's not good. Yeah, Mac Pro running on a single E-core. Let's not do that. Did I get something wrong in the CPU start? I mean, I would expect it to be the same as 6020, but who knows now? Oh, actually, no. I bet they moved something in P Manager. Wait. No. Hold on. That's just the hypervisor, isn't it? Yeah. It's the guest that is having trouble because the hypervisor doesn't know what it's doing. Okay. No. It wouldn't boot after failing all that. The Mini doesn't even try. Okay, now it's starting those. And it did not work. Unable to find alias ACIO. Those are fine. Okay, the GPU stuff is failing. OPP microvolt for power state 0. The numbers look kind of good, at least. So, you know. That's a lot of watts. 157 watts on the GPU. Failed to set OPP microvolt for power state 0. Because the table count is something is missing, I bet. The die multiplier. Is this doing the die count right? Oh, no, it's not. Yeah, that's very hard coded there, isn't it? No. Let's not fall through there. Until sleep 2 a.m. here. Okay, see you later. So, that looks like Linux, all right. Got NVMe working, the partitions and stuff. USBs, okay. It mounted it. Why is the... I mean, it mounted ButterFS and everything. Kinda, yeah. But, like, why would init not work? Kind of works like everything's crashing. Kind of looks like everything's crashing, but... Well, it's the only ButterFS partition, right? Because the... Yeah, it should be right. I think this is just Fedora being Fedora. It even got the ALSA device. Yeah, does it have to be systemd on Fedora, or is it because you have to use the initramfs like necessarily on Fedora? I don't even know if I've ever booted Fedora like this explicitly. Is it like that? Has it been systemd? Is it just because I need to do that? That wouldn't surprise me. Yeah, BNSH fallback should work, so why didn't that even work? Oh, okay, it needs a subfall? That would be why. Aha! That looks like Fedora, all right, and a lot of things complaining because probably don't even have C Linux or something, but hey! Okay, I don't have a console. Oh, I do actually. Cool. But I can't log in because I assume there's no default root login here. And I'm not running the the setup configuration program stuff because there's no graphics. Hey, thanks for the super chat. Okay. Yeah, I need to BNSH this, don't I? Either way, I don't really care about user space right now. No, because this is the KDE image, so it's probably trying to run the GUI like KDE setup. Okay, here's my console. I guess maybe it doesn't like that. That doesn't work. There. What is... Yeah, auto relabel is set, so probably isn't doing that because of Asahi Linux not even being supported. I don't care. Give me a root password. Yes, thank you. And yeah, remember, this is like a random kernel I have. It's probably missing stuff Fedora wants. Yeah. Would not be surprised if things are broken here. Hey, got it root shell. Okay. Yeah, let's disable that because it seems to be broken. Yeah, I could, but I'm not going to change the kernel. Anyway, I got a root shell. That's all I care about right now. So I guess PCIe, because everything works as we kind of expected it to work. Of course, there's no Ethernet because there's no PCIe. So the machine has Ethernet, yes, but the fun thing is that that's behind the PCIe bridge now. So what I'm going to do is I'm going to first just blindly try setting up the PCIe G stuff. And just guess that it's the same as the other PCIe that is compatible. See what happens. Might go very... I could... Okay, hold it. Do you have USB? Yes. Okay, so we have USB. The track point isn't there. So I could attach a USB Ethernet interface and use that. So that means the Type-C ports work. The Type-A ports are behind PCIe, so those are not going to work. But it means I did the right thing with all the stupid USB like craziness that I copied and pasted there. So yes, USB works, which is exactly what I expected. So what do you mean what? You haven't heard the story of how PCIe is invented in this machine? It's kind of ridiculous. They have an 8-lane port and a 16-lane. Yeah, but that's the same on all the desktops. All the desktops have the Type-A ports on PCIe. Yeah, they have 8 lanes on die 0 and 16 lanes on die 1 going to a giant like enterprise PCIe switch that then routes them into a bunch of subports, and apparently it's dynamic and you can change the routing, which is kind of crazy, and I have no idea how that works. But maybe iBoot configures that, and all we have to do is just bring up the root, the bridge upstream port, and then Linux will detect everything. Yeah, no, it's a very fucked up PCIe setup because they didn't have all the lanes they needed on this chip, and they really wanted to make this machine and get it out. And this was the backup plan. This is very obviously Apple's backup plan. Like, they just wanted to get a Mac Pro out so they could get rid of Intel. This is not the original like Mac Pro plan. They had something better in mind and scrapped it. It's alive, yes. Thank you for the super chat. No, it is really fucked up. But the question is it going to work on Linux relatively easily? And what about that GPU? Did they fix the mapping stuff? Okay, reboot. Let's just kill that. And also PCIe needs initialization in mini. Wait, what did that even do? I don't have my logs here. Let me do it again. Because I want to know what Mini did about PCIe, because PCIe needs a bunch of fuse nonsense. And that's... maybe not applicable anymore. Oh, wait, no, because it's not going to find the PCIe. Yes, okay, it's not even there, so it doesn't even try. Okay. Which means we are, I think, definitely going to need the hypervisor on this. So, do I have 13.5? I think, yes, guest kernel, not guest kernel, list.py, but not that one. That one. Do I have 13.5? No, I don't. Okay. I do have this one here. Whoa. Apparently I have the whole PSW. Zip, universal Mac, kernel cache. Let's just get all of them out. Yeah, ZSH knows a bunch of stuff like that. Yeah. I mean, of course, with the switch you can do dynamic reconfig, but what I don't know is whether that is configured by iBoot or whether macOS does a whole bunch of crazy initialization that I don't know about. Audio is work in progress. No, I want to get the Mac Ultra, this one, the M1 Ultra, worked out. No, it already boots, so it's already good enough for that. Lena needs to bring up the GPU, among other things, because we want to submit for conformance testing, and that, the sooner that happens, the better. So let's trace piece. Oh, that's going to be really confusing. Yeah, this is okay. We're gonna need to do a bunch of stuff. Asahi git mini proxy client. Let's copy that. Let's call that APCIe GP. And this is just tracing everything on APCIe. So let's look at the device tree again. ADT, Mac Pro ADT. So we have APCIe G0 and APCIe G1. And they are just both sides of the die, so that's all reasonable. So we're going to just trace everything in G like that. And I kind of expect fuse nonsense, which is going to be that, probably that address there, or that one. I mean, I kind of guess that the way I would do it is that iBoot does the initialization and it goes in the NVRAM what the config is. But I have no idea. So, because I think the switch is also an I2C or something. This could all be Mac Pro APCIe G. That's what it's called. Rename. (13.5) kernel cache 14J. Okay, so now we find out whether the hypervisor works. Well, no, it does. I mean, it works on Linux. I'm going to find out whether it works on macOS. Looking good so far. Yeah, lots of stuff. And lots of PCI fun. But that now is starting to look like actual drivers. Yeah, it's a lot of stuff. But I think that's probably actual drivers now. So I'll have to look at the top and see how it starts. Actually, I wonder if there's any debug logs. C, PCIe C. Hey, Apple P. Oh, well, there's our. There's our switch. It's from microchip. At least it's a public thing. So it definitely has drivers going on for that thing. Up to 100 lanes, and they use that one. And an integrated MIPS processor. Yay! I like that TLP generator. I could use that. Yeah, at least it's not Broadcom. Up to 11 I2C inter. What? 100. Is this a PCIe switch or a freaking microcontroller like SoC? The question is there a data sheet for this? I bet there isn't. Cell sheet, brochure, and of course, no actual data sheet. Yay! Does anyone have a Linux driver for this? Someone has a Linux driver for this, apparently. $800 for a single unit for this thing? Yeah, no wonder the Mac Pro isn't cheap. Dev switch tech 0. Why is that under microsemi? Did Microchip buy it from them or something? I guess they bought this. Okay, so I guess, yeah, it should just work as long as PCIe works. Okay, so what's Apple doing here? PCIe current speed, retrain link. Okay, so there's a terminating thing, there's a mapper offline. PCI configuration, bridges 10, devices 6. Okay. Bridges 8 devices. It's adding stuff. Okay, it's doing like Broadcom stuff, so that means it's seen that before. Huh. Oh, is that a panic? Oh, it panicked. Oh, it's pin lock timeout. Okay, it's probably just too slow. Yeah, that happens sometimes with the hypervisor. Okay. Well, we have a nice log anyway of a lot of stuff here. So let's see what we have there. Okay, G0 reads stuff. This looks like fuses. This is fuses. This is totally fuses. Now I'm wondering whether the fuses have anything to do with the old ones or whether I need to look for the new fuse table. So I usually just look at the driver for that because it's a pain in the ass, guessing where the fuses are, like experimentally. So on T, oh wait, we don't even have T62X. Did we never implement that? No. Did it not need that? Yeah, I think I remember we didn't have fuses for Type C, and I guess maybe we don't have for this then. But now apparently we have fuses. So, okay, what's in the device tree? G0. Okay, AXI to AF tunables are in there. That's probably one of them. Yeah, I think this is just the AXI to AF. So that means this is actually compatible. So then we just move that on here. Problem is that now this is going to be split between two ports and stuff. Yeah, now all these globals are now split into two. Heh. Yeah. Yuck. Okay, so APCIe controller, APCIe. So we're gonna just clean this up. Struct state. You actually need to declare that. State, I'm controlling the static. We got static. CA init controller in controller. Struct state equals state. Controller. Let's call it states. Let's go to controllers actually. Port count. And then we check that. Continue. Okay. PCI initialized false. State initialized false. Yes, PCI shut down. No, success because only either that or the other two are going to exist on any given machine. So if I'm going to consider if any of them succeeds, I'm going to consider it successful. And then it's going to be a ton of state. Oh, fuse bits is it's just there. At least the that's config base. Did that go somewhere? Oh no, that isn't there. Okay. PCIe Rex 243, missed one. It's more than one. Okay, builds. Let's also set the initialized variable to false. So we want here is controller initialized false state. Set to false there and true at the end. I don't need that. I do need that. Okay. So that we'll see whether Mini. Yeah, let's see if Mini picks up on. No, wait, Mini's not going to pick up on links. But let's see if the regular init sequence works at all. Oh, there was an unsupported compatible. Okay. Yeah, so that needs to be. It's 6020. APCIG. And yeah, we're just going to wing it and see if it's the same. Ooh, okay. So we have Axi2AF. Oh, 50 IPPLL tunables. And we have 2 5s. Oh, we have a lot of 5s. Oh, because right. So this is yeah. Because the 5s are split now, because it's a bunch of ports ganged up into one multi-link multi-lane port, which is why and then this one should have even more. Oh, this one has fewer 5s. Okay, so then right, because the storage is on the second die. So I got that wrong when I mentioned it on Fetty. The first one is the one with all the fun lanes, and this one only has 2. Okay. Okay. Phi IP PLL tunables, and then I need Phi 0 IP PLL tunables, and then it's going to be fun what the offsets are for those. Is there anything interesting here that tells us that it has a lane config? Yeah, okay, so it has, the layout is different. We have eCam, RC, and then a bunch of PHYs. Three PHYs? Because index 5 is PHY IP for the new one. Maybe they're just combined. So then we just need some offsets on that. Let's look at the log. So 6 should be Axie. Yeah, Axie to AF, and these are the Axie to AF tunables, exactly, yes. It does for both G0 and G1, and then it's reading a bunch of crap from Axie to AF. Okay, then it does 4. Then you get to 5. Yeah, that's a lot of stuff on 5. It does read, write. $50.80. Okay, there's a bunch of stuff on there, yeah. They're getting offset by something. So what do the actual tunables contain? So phi 0 is that, and then phi 1 is what? Looks like the same offsets. Okay, so let's look for the phi IP tunables. We're looking for offset. So phi gets applied, because there's also these, right? That gets applied to phi index, and then we're looking for phi IP index, which, just to make sure again I got it right, that was 6, I think. 5, sorry. So it is 5. And so 12, is that 1204? No, that's 1204. I should, why haven't I parsed these tunables yet? I should do that. I keep looking at these hex blobs and it's dumb. Let me just fix that in ADT. You don't have any tunables in the ADT. Yeah, let's fix that. Tunables apply, what is that called? Tunable global. Regedex. Hex int 32 ul, comma, offset mask value, offset mask value, and tunable local, offset size mask value, offset size, and these are 64 bits. And then the PCIe stuff is local, okay. These are all local, I think. Yeah. Right. No need to read that. Greedy range has no attribute items. Why? Oh, because right, these are the compats. Much better. So we have, oh, it starts here. Okay, I was just confused. It starts here in 1200. The problem is that we have two CPUs doing two things at once, which is why this is getting confusing. So it reads 1200, it writes 1200, it does all that stuff. And the last one would be 62 BC, and then it does the IP. Yeah, so 62 BC is around there somewhere. And then after that, it does 810C, which is the APLL thing. It's also doing the other port at the same time, just getting really confusing. Then, okay, so then it jumps to what? Phi 1. Oh, no, it's still doing that. Okay. Then Phi 1 is still 100 again. So the last one there is 21030. There, 21030 and D0. And it does a few of them, actually. 230, yes, okay. Now what? Then we should be back to 1200. Ah, for 1200. Okay, yes. So it's doing 4000 there. There's probably some extra stuff that goes with the... That goes with each Phi. Because that's in 4. And that means that was probably 0 on this one then. Yeah. Okay, so it's 0, and then so the stride for that one, Phi stride is and the Phi P stride was what now? Is that 4000? And so it's doing the Phi control 0, the clock axe and all that, setting the requests and looking for the For the axe, yes. Okay, so it does the clock requests, which means we need to loop this. It does the clock request last. No, first. And then it does this 5p tunables thing. Okay. How do we know how many phis we have? There has to be something for that, because this doesn't specify. There's len config 0 and then len config 1. That's not that nice. That's kind of annoying. Yeah, I guess it's going to be the len config. Yeah, there's nothing there. Anything after that? Nope. So I guess it's len config. Okay, so I just need to read a property there. Yeah, so we have num5s, let's call it 1 on that, and then on this one, so length CFG, get prop, ADT offset, lane CFG, G. But I don't want ADT get prop, I want ADT get prop, not offset name val. Config and lane config for path, return -1. And then switch lane config, okay, 0, num phis equals, that's the one with, 2 phis. Okay. Let's put that on the top so that when it fails, we know about it. So num phis, and then we need to loop the whole phi thing. So common phi tunables, and then the stuff that loops is, yeah, 5, 21, 30, and then it goes into offset 4, which is unknown. That one, offset 4. No, it's RC base though. That. Ah, yes. Okay, so it kind of starts here. Phi base after the clock requests. Is it? It's still the old one. And then it does 4,000 for... Yeah, okay, so it starts there. And the clock requests. So we need a for loop here. Phi comment is set. Okay. For int phi equals 0, phi equals phi plus plus. And then we apply the tunables, and then the +4 phi common phi base. Okay, so I think it has to go up to here. And then in T62X, this would be common code. Because those are really complex stuff. Okay. Phi base. What about the phi common there, though? It sets bit 10 on that, and then it goes into the next one. Okay, so it's just that one then. I'm not sure if that common code needs to be phi control 300. Does that all happen at the end? That's 0. Yeah, I don't know what that is. So we have 4,000 there. Okay, let's search for the phi control. Okay, then it's doing bit 200. And then 300. So it does that on all phis at the end, after all this stuff. Then it says the root complex. Yeah, 130. No, 21,000 apparently, but okay. So then C004 is that. Then it goes into RC base plus 0. Oh, that's this one, isn't it? Yeah, okay. Okay, so this has to go just that. And then it would do phi base plus 8. Yes. But only 4,008. That's weird. It only reads it also. And then it's setting this one. Oh, because it only checks. Okay, so it only checks a random phi base for the clock. And then it's doing that for all the phis. So it needs another loop there. Phi base plus phi times phi stride Yeah, like that. And then it does all the port stuff, and then are we touching the PHYs at the end? No, it doesn't look like it. We do that, so this also needs to have a loop for the uninit. And that means num5 needs to go in here. Because then I need to reuse that. Put that in here. Phi base, phi stride. Phi base. I'm tempted to just make that a... Yeah, I'm kind of tempted to just make that an array. And then it would be just phi here. And 0 for that one, we don't care. That's actually phi. State num5s. Then here just phi base. And then when we set that, just read that into phi base 0 and phi IP base 0 and phi equals 1, phi state num5s, phi plus plus, state phi base phi equals state phi base 0 plus phi stride times phi and phi IP. Phi IP base, IP stride phi. It makes it a little bit easier that way. Okay, does that compile? Yeah. And then if we need to get the proper strings there. Let's call this, what is that called? What am I looking for there? Property. If num5 equals 1, it's called PL prop and now it's PMA prop. Let's just copy PL prop. That's PMA prop. Do I need string H here? Yes. And then these are called phi IP, phi1 IP, okay. That's in string, that's in, I have sprintf, I have sprintf. VS printf. I don't have, yeah, it's, do I not have sprintf? Apparently I don't have sprintf, okay. Wait, oh, I'm sure we've done computed properties before. Really? No way. It says SN print. Oh, it says SN printf, isn't it? It's just that it wants. Yeah, okay, makes more sense. Okay, compiles. Let's add all this junk. Amend. Okay. And because I think Linux doesn't touch the phi IP registers, I think this might actually work with Linux once I just add the device tree stuff. Okay, so I got the Linux at least. Let me just see what it did with PCIe. No, that didn't work. PCIe 5, nope, that didn't work. Why did numphies not get set? Oh, I think I didn't. I think I didn't use the strings. Yeah. Thank you for existing. Thanks. Whoa. That is an exception. Data board, though. Did I do a lot of bad math somewhere? That looks wrong. Can I get a stride somewhere? No, that's fine. Oh, I have plus phi. Ah. Sorry, I just totally missed that. Yeah, it's just as an align. That's why I aborted. Okay. No, I just didn't see the message because I'm dumb. Because I'm not paying attention. Sorry. Ha. PC 5 clock enabled timed out. Okay. So 5 clock enabled timed out. This is interesting because I was reading 4008. Maybe it reads the last phi. Which log was I looking at? Ah. That's in G1 4008. And in G0, let's search for that with a dot there. And also there. No, actually. One two zero eight. It's in G1. No, they're both in that one. Okay. Okay, that is kind of ugly, but let's put it here. Yes! Now it works. Okay, so it has to be that one. Initialize controller. Okay, now controller 0. That is wrong. Why is it controller 0 twice? Oh, I think I messed that up. Yeah, it has to be like that. Okay, so that might actually work. No need a dot there. Yes. Just double check that it's actually formatted. Apparently I messed that up. And that would be that one, except for that. Erase that shine, fix up on there. Okay, let's compile. And yeah, I guess then we just throw this stuff in Linux and see if it sees a PCIe switch and a bunch of magic behind it. Yeah, initialize controller 1 and 2. Okay, cool. Linux time. So, this one is in die 0, APCIe. And now the new one is going to be in die X because it's in both. So we just copy and paste this entire thing, including the darts, but now we're only going to have one dart. And that goes in die X now. And what are the addresses here? Let me pull up the device tree in Mac Pro ADT, pull it up in a proper editor so I can see what I'm doing. APCIe, G0, okay. So in die, don't care, die X, this is 168 something, so it's pretty high. So it's going to be down near the end. It's actually the last thing. Okay. So PCIe G0. Actually, PCIe G. And this is die node now. And it's at 168. Just a very different address. T6020 PCIe. Let's just use the old compatible. Actually, no, you can use both. G. And then this is becomes 16. And I think everything else is just the same. 91 would be RC. And then there's only one port. 48,000. Yeah, that looks about right. 90, we got phi for the port, just 9E. Not sure about that. So the order here is, let me look at the, eight rags shared. So this is config. I can't edit now. Just put it in a file. RC. Don't know what that one is. This is common. This is phi. This is phi IP. XC, fuse, and then we have the port stuff, which would be config, DSSM debug, phi, and phi IP. Okay, so then in the device tree, that becomes port 0 would be the config, 64948,000, yes. Phi would be apparently at 1C. I guess it's the last phi then. No, it's always 1C. Okay, easy then. Easier for me. So phi is at 1C. 9E1C. And then phi IP... Sorry, LTSSM debug is at 401C. So that's right for that one. And then we just have port 0 and phi 0 and LTSSM 0. There's only one port here. Next up, the lovely interrupts. Where am I? MSI Vectorcraft at 1672. That is the same. Interrupts 1356. That's interesting, but these are 4 here, though. And are those the port interrupts? I also feel like they didn't do the tunables there. Port count, number of ports is 1. Oh, but it's called, yeah, that's why. Okay. So we didn't actually initialize the ports. It should be PCI G0 bridge. Yeah, that's annoying. Okay. Yeah, so we weren't doing the bridge in it properly. Hopefully that's all standard, though. And then, what about the interrupts? Let's look at the into max ADT APCIe. So the interrupts we had before were 1340, 1344. Okay, so those are probably per port then, which means the there's the interrupts. $13.56 is the only one for that one. So the per port interrupt is different, but the MSI range is the same, which kind of makes sense because the other use one of the other controller. And there should only be one IOMMU and one Dart for this. And then we're going to have to look at those ranges also. Oh yeah, that's V16. The IOMMUs, there's a single Dart, I believe. Yeah, Dart APCI G0. G Dart. And that is a 1694, exactly as I would expect. And the interrupt is 1357. And then I think the power states are also different for this one. It should be APCIe G or something, because I'm pretty sure that was in there. Yeah, APCIe G sys, so it's definitely going to be that. And also this one. And then the pins are going to be G pins, and we don't even know what some of those pins are. You map mask, I don't know if that is correct or not, but it's going to be PCIe G Dart. State. Disabled. Is it state or status? Status, right? Disable that and disable the Dart also, and then enable them in the T60 J180D. Status okay. CG Die1. Die1. So this is all conditional, and that being that, then as I said, we only have one port, so that goes away. Pin control. Where is that? PCIe pins 0, 1, 2, 3 for the ports. PCIe GP pins, G pins. So the pins we want there are, should be a single one. So on this one we had, yeah, clock request as GPIO 0 and reset as GPIO 4. Yeah, so this is the clock request. And then that means the clock request for the new one and this is now per die, which is a bit annoying. PCIe G0. Let's go to the port. Clock request is pin 8 and reset to 7D. 7D is 125. Okay, so reset is 125. And this one is pin max 8. PCIe G pins. But now we have 2 of them. Ooh, that's going to be a bit annoying because it depends on the die. It's the first time this depends on the die. I can just if-def it though. 7D. So we have 7D and 8. Oh, BIOPRST. That might be the... Four clock req 0. Yeah, that's new. That might be the PCIe reset of the device. No, but it should be the... I don't know what the BIO PCIe PRST is. Unless it's the reset of the like subboard. No, G0 has clock request at 8. And then we have like, oh yeah, it's all the downstream PCI resets. Yeah, it's going to be annoying. And then there's other stuff. There's like mode GPIOs and USB-A and other RC PCI resets 9. But why are there 2 of them? Oh, there's Oh no, because the GPIO controller is. Oh, okay, it's on each die, is what that is. It's the. Ooh, okay, that's funny. Ha! Huh. It's per die, isn't it? Yes, there's GPIO now on the second die. That's also new. I think. Actually, no, it might not be. 39. 219. It's 19. No, this is going on AP, so it should be here. GPIO0 is on 19B. Why do I have this in 39? Is this wrong? Oh no, that's that implicit offset thing. Yeah, that. There's a thing in the device tree here that adds the 2. So that's spin control AP. And this is just 2, 3, 9. Yeah, okay, so that's fine. So we do have pin control AP per die, which means I just need a it's pin 8 on both of those. APCIe G0. And so then we have 260 is the first controller. And this isn't GPIO pins, which is interesting. I guess we might as well put that in the other one. And just go into 6022. G pins die 1, and then we can also use the same die thing here. Pin control 0. Die node. G pins. And then there's only one dart, as we said. Bus range is 1. And so then I assume G1 bridge has reset on 9, clock recon 2 on 8. Clock recon 8, reset on 9. Then G0 has clock recon 8. Where's reset? 9. Okay, so it is 9. Which means this one. Trip map mask. I don't know why that's 7. Reset GPIOs would be 9 with die node. And then the ranges. 43,018, 18. So this was, yeah, I think we just add to that. This was on die 0, APCIe. It was 5. And it's still 5, okay. Let me compare it with the other one. Yeah, so this one has 43805. Yeah, so it's the same as that, just the different that, and then it has 2C0. Two C0, 5C0. Yeah. And the length. So it is right, it's just the different order. So it's 18 on this one. Ranges 18,0. 18,0. And I think the size is bigger. Oh, it's way bigger. Yeah, that's why they moved it, because the size is, they need to accommodate a lot more address space now, so they make that way bigger. And then this one is also way bigger. So it's twice the size for that one. And this would be bus address 8,000 apparently. And then 5 would become 17,8. I think those are the ranges. And then presumably die 1 is the same with the offset, the die offset. Okay. Oh, there's a crazy... There's a crazy device tree change, and of course I have some syntax errors. 365. Semicolon. Duplicate label port 00. Oh. Close. Semicolon. Semicolons everywhere. (14.1). What? That. Dart DCIG Dart die 1 die node. Okay. Oh, dino, that's right. Interrupts need the dino. You are very right. I assume MSI also has the dino there. Actually, no, it's not. Oh no, but I think that's just the regular core offset. 17 plus 4096 or something. Yeah, okay, it's that. Yeah, it's just that. That should be fine. Let's add all that. DTS Apple T6222. Say G nodes. And we run it and see what happens. Let's see if the port init works, because I also fixed that in Mini now. So let's look at that first, and then go down and see what Linux thinks about this. Yeah, this doesn't complain. Okay. Let's actually get a real shell here. I haven't even looked at the messages. I want to see if LSPCI shows anything. No. Missing reg property. But I have a reg property. Why do you think I'm missing a reg property? PCI, no, PCI controller, PCI pull. Where's the missing reg property? Probably just index that because I have a lot of junk. Non-prefetchable memory resource required. Yeah, just see if there's any other messages. No, this got cleared. The Jart as well. Oh, the interrupt. Yeah, you're right. Why is it saying missing reg property though? Oh, is it because my ranges at the top level are wrong? Probably. Yeah, but these are wrong. Yeah. These are wrong. It's not missing the reg property. It's just it can't translate it. What are the top level ranges on this? Just to see the same thing. Yeah, like that. So let me just print this a little bit. Yes, 258. And then we have 7, yes. But then we also have 168, which I didn't have here, is the issue. Six, 8. And the size is 5, 8. And then that's just the second die with exactly the expected things. I don't know why I don't have 5, 8 on that one, though. What's on there? Should be die 0 only. PCIe is at 5, 8. That's why we don't have it on die 1, because we don't need it. Yeah. And then this would be 3, 6 there. Yeah, okay. Woo! Okay, I think I know what that is. That's a dart that isn't turned on or something. $16.94 is faulting. Yep, that is very dead. Okay, let me just play with the P manager stuff first. Yeah. Okay. Phi switch is an actual, okay. So it has G-sys. And also Phi switch. I don't know why storage is in there. Oh, but that one's always on, though. Okay, so that doesn't work yet. So the actual power state for G is GP, GGP, Phi switch. Okay, Phi state. Phi switch should be on. Then we have G and GGP and ST1. Is it ST1? All these are on. Oh no, right. The Dart needed the clocks for PCIe, so that means the clock stuff isn't working. If I remember correctly, we need to turn the clocks on PCIe first for the Dart to work, which means that's broken because the or chain load this one in. But it's not working. I think the port thing didn't work. Yeah, we're not getting here. Why are we not getting there? Oh, because it's not APCI. It's yeah, it's G0. Yeah, and I think those go with the port. It's APCI G0. Yeah. Aha. Port failed to become idle. Okay, so that didn't work. But Linux did not crash. PCIe is not happy. But it did try to initialize. Yeah, link didn't come up. So the port in it is broken. And then something. Oh, no. Apple PCIe bus notifier. The problem now is that we have two buses. And there's a double thing there. Probably. Yeah, that's a different problem. Yeah, I'm running on this on a Mac with Asahi. Yeah, okay, so the second controller is borked, but also at least the Dart thing is working now, so that means we're getting a bit further. And then the problem is that the PCIe and it is not initializing the port. So let's reboot that, chain load, and we can port failed to become idle. Yeah, the ports are bork. I guess I'll have to look at the actually, this wasn't a VM, but it's a VM on the M2 Ultra. I mean, there is no OS. It's a custom VM. It's running. It's a VM, but it's not a VM. Basically, I'm rebooting the machine every time I try it. This machine you're seeing is not the M2 Ultra. So we're kind of getting there. don't know if it's the first one or the second one that's fitting, so let's just try that. Because maybe it doesn't need that workaround. And we can just run the PCI init from this and avoid having to... Yeah. Okay, so it's failing on the first one. So yeah, we got to look at the logs again and see what's doing at the port. APCI EG0. The port stuff would be offset 8. So we're looking for config and that stuff. So E0, 8. Okay, there we go. And what it's doing is this stuff. It's not doing this, apparently. RC base 3C, it does do that. Set the Radeon on that, which is low reset. Then it does... That 10 doesn't do. 48, 80, 84. Well, that looks pretty similar. 800. 82C. The MSI map stuff, which I don't care about. And then... So this might be it if controller equals PCI, just in case. Let's just guard that. And then we have 130. Apparently there's an 8 there. That's interesting. Else, just in case. And then 140 gets 10. One 144 gets that. 21C, 834. And there's more now, apparently. 83C. And this is tunables. I think it might just be the tunables. And the port there, config tunables, is, I can't read that anymore again, but I can see it's 130. Yeah, it's 130. Okay, so we have 834. 83C is new. And then we have the config tunables. Which get applied. It starts at 130 and then 140 and then whatever, 44. 21C. Wait, 144. Actually, no, this is still not tunables. Tunables starts here. 130, 140, 144, 14C. And then it goes into, yeah. So this we're missing. Wait, A3C, no, it's turning here. Okay, no, that is right. A3C. After the tunables, we have the RC tunables. It's the 78 thing. It does the clock enables are working. App clock is 800. Yeah, that's app clock. And then those are the So 14C is the last tunable. Where's the RC tunables going? Oh, those come after, okay. Okay, so let's look at those. It does the clocks, as usual. It sets, clears 4,000, sets 200, 400, then 82C. Okay, let me just look at this on the other side. Yeah, 82C is reset. It sets, reset, disable. 82C, yes. And now we're getting stuff mixed up with the other thing. 804 is reading port status. And that we do get right. 804, status run, yes, so it's reading the 1 there. And then after that, it goes and writes the 9. Oh, okay, there's more stuff now. So between that and the idle thing, 10, 1, C20, isn't that the, that's this. So it's doing that, 2, 4, 2, 1. I don't know if that doubling thing happens. I don't think so. I think that's other stuff now. No, that's other stuff now. So the last thing it does is 804 port status. That's fine. And then here, if fits and controller is not equal to APCIE, then we need to do that stupid dance. 2, 4, 2, 1. And it's G18. 2, 4. Reads. And then sets 2 on 20. Then 1 on 14. And then it's clearing something in 800. Link status is 208. So that's right after that. And then it's polling link status. Okay, so we need to just clear that on 800. App clock. I think we don't need that, but might as well do it. I think that's the clock gate disabled or something. Okay, let's see if that initializes the ports now. Reboot that. Nope. What we're polling for here is link status busy, which is bit 2 of 208, which isn't even set yet. Let's see what we have there. Oh, no, bit 2 is 4. Sorry, that is the 4. And it's just waiting for it to clear, which it does on this one. Yep, it's stuck at C3. Okay, I guess we're gonna grep for a PCIe G0 here and do a bit of a cleaner pass. So it reads a bunch of fuses, but it doesn't seem to use them for anything. Then we have, let's go from the beginning and look at the old auto init. First thing that happens after all the get regs, so it applies actually to AF tunables. I think we have that. Yeah, so we have 0, C10. Yeah, okay, so those are just those. Should end at 800. There. And then it applies the phi IP tunables. No, then there's some other stuff there. Next to AF tunables, it writes... Okay, we're missing stuff there. It's enabling clocks and stuff now. And then does that. That's offset 0, which is the phi control. Offset 4 would be phi, yeah. Oh, wait, where is the phi? Oh, there's no phi tunables. So what is this little dance here where it's going... But is this the RC base? No, this is phi base now. This is a different thing. Okay, this isn't used. Then it does do offset 0. Yeah, phi common. So it yeah, that's the pole. And then it goes and initializes the phis, and then it does the phi clocks. Okay, so that is right. So then what we don't need is this one. Just say control PCIe. And then it's doing the clocks first. Then set 3254, yes. Okay, so what I'm going to do is run Linux again, but trace it. And then we can just look side by side and it'll make a lot more sense than trying to compare with the code. That didn't work. Actually, let me just try this thing. If I reset this underscore bang. Yeah, it looks like it works. Cool. The central scrutinizer is doing its job. Yes, I use Kate. I'm also getting hungry, so I hope we can figure this out pretty soon. Oh, did I mess that up there? There, shell. I totally messed this up. Yeah, like that. Oh, I guess no need dashes in that case. There's our init. And why did that not work? There. Yes, I get it. You're stuck there. So now we can just compare side by side and see what is wrong there. Why is Linux reading a bunch of crap? Isn't that fuses? It's like the same kind of stuff. Oh, no, okay, because the fuse ranges are the same for everything. So there's other stuff that uses fuses, like the GPU or whatever, and that's why that gets read differently. Okay, whatever. So those are not PCIe fuses. Well, that is very identical so far. That's good. Oh, something's different there. There's extra stuff. That's right after... Oh, no, it's just reading, though. It's just reading a bunch of stuff. I know why it's reading stuff, but we can skip that. Read, write, read. Yeah, that's just the slightly different timing. There's some duplicate writes there because we do the tunables differently. Oh, yeah, okay, that's fine. Again, the delta stuff is different there, but that all looks fine. That is all very identical. That's make my life easy comparing. Yeah, that's all the same. Okay, and this is where things get weird. Oh, wait. Did I miss an offset? That's not using the offset. Oh, because the tunables don't get... because that goes straight for the index and it doesn't apply. Okay. There's a reg offset, but then I need a U32 offset, and then that's gonna break my compile everywhere. Tunables. local. Oh, okay, no, this is what I want, the address property. Path prop base. And then what I want to do is use the IP stuff there. IP base. Cool. That means we were very off on that. Yeah, all of those are off by that. And then, yeah, all those are just kind of offset, but let's go all the way to the end here and see 9A, 9C, 9D, yeah. Just to see how far off it is. And then we have that E1 something, 30, yeah, that's there. So that's the end of that, and then just compare the rest of it. Okay, that looks the same. Except, oh, no, actually. Oh no, because the Mac the macOS does those bits separately. I do them at the same time, but I do them in the right way. I think that doesn't matter. Read, right, read. Oh, okay, we're not doing that. 3C. So Mac OS is just setting the bit. We are clearing it and then setting it. Where are we setting that? Oh, there. Okay. Okay, let's do it like that. Let's also gate that one because that could be weird. And then it's all the same after that. Oh, there's more. There's more MSI maps. Okay, that doesn't actually matter, but it means that we're going to have to move some registers around on the Linux side. 39FC, 3FFC, and then there's 397C. Okay. But all that is the same, though. And then it says 800, and then, yes. And then everything else is the same. Okay, so we've copied the whole thing, so this should work. Chain load. Whoop, that is now broken. Null pointer deref. I'm just going to printf some of this stuff. Easier than trying to figure out where that is failing. Though it was plus 80, so it looks like port base is wrong. But we did read the regs, so... Yep, still trying to get a PCI to init, but I think we're pretty close because I'm pretty much copying everything right now, so... Where is this failing? It gets to D, and then it crashes. Means we're getting better. We're getting closer now. Is it the tunables? Oh wait, isn't config base? No, that is right. Gets the E. Okay, where's it failing now? F. Also, max linked with one is a lie now. I need to not do that. Let's put that in here. So it'll be 16 lanes for that one and 8 lanes for that one. I'm just guessing here, but this makes a lot of sense to be like that. Lane config, is that right? No, lane mode. And then the link width is the same thing. I think that's right. That's not what's failing right now, though, but... And I think also link cap is... That's a standard thing, by the way. I think that's not a bit field. It's just that, so it'll be like that. Oh, is it enter to exe? Oh, it's that, isn't it? It's that what's failing. And the reason for that is port rec count greater than or equal to 5. Why is that not 5? Port count. Hold on, I think it's not 4, it's 5. Why did we end up with 4? I think it's 5. Maybe it isn't. Maybe that just needs to be gated. Enter to exe. Maybe it isn't that. Maybe it isn't 5. So the ports are... No, it is 4. Okay, so we don't have enter to exe, which means I just need to get that. That's my crash, which means we're getting pretty far. It's max link width. Let's just set that properly. Let's remove my debug prints. It's just Kate, not kdevelop. Okay, now it initializes. I can get rid of the port-based thing. It's more debug. And now we try Linux again. Though, as I said, the multiple controllers is a problem. So let's actually try to fix that. Linux drivers, PCI controller, CIE Apple. So the problem here is that we have notifier. We have a... Yeah, that is a bad idea. That needs to go on the controller. PCIe probe. How do we get more than one notifier there? If Apple PCIe, that is coming from domain. Yeah, it's coming from RQ domain host data. Port PCIe port. That is coming from the data there. PCIe port config priv. It comes from the config window, which is the pdev sys data, and the PCIe there is coming from Apple PCIe init. I need to move the notifier there. So that creates that in the config window. I wonder if we're allowed to mess with the platform data for that. What is that used for? that is used for... yeah, this isn't going to work. It doesn't hold anymore. Good job. Okay, that's... yeah, we're only going to get the first controller initialized. If any. That's going to be a story for another day. And, yeah. All right. Okay, hold on. Don't need to log that anymore, I think. PCI Apple, yeah, that one fails. Link up! We gotta link up! Bridge configuration invalid. Reconfiguring. Cannot insert conflicts in sub 3202. Something PCI bridges. And apparently some of those controllers are broken. 3D and 3. Did I get the things wrong? We have a link up at least. So that should be something. Hey, PMC Sierra Inc. device 4000, that's the bridge. And nothing behind it, probably because the PCI reset GPIOs are still in like screw you mode. But that's a start. We got to the bridge with no code changes to Linux, except the problem that we only have one root port now. So can I... can I mess with the PCI reset like manually, and maybe it'll even hot plug? Hold on. Pin control is where? So the PCI resets. Yeah, let me just do a quick hack. I think I'm going to be logging off pretty soon because I need to get some dinner. But yeah, this isn't bad. That controller thing with the single controller is going to be quite annoying. So where's my Mac Pro ADT? PCI G0. We have G0. That's the one that's initializing. It did get the bridge behind that, and so now I need the port and the PCI reset. And so if I some of these things have power controls, which is a bit annoying, but at the very least the reset USB-A, WLAN BT. There should also be Ethernet. And there's what BIO is, though. So they're all on 260. I also need to look at those modes. I have no idea what all those modes are. Maybe it needs to be set before it or something. Or maybe you need to do some actual communications with the bridge for it to work. But let's try to get the USB-A up. So that's 260, which is the local, the pin control. And so pin control in here. We don't need that yet. So pin control is not nub, AOP, AP is here. So if I just read that, that's good. And then that is just offset by the pin count, I remember correctly. So it's 4 times... let's try to get USB in. So that's 6. And then what are the bits on the GPIOs there? Linux, drivers, pin control, Apple GPIO. Data is bit 0, mode is That out is 1. So I think I just do this. No, that didn't do anything. That is a inverted signal, though, isn't it? Yeah, it's inverted. So 1 is correct there to turn that on. So 6 is USB-A. 9 should be... Yeah. The local one, what's BIO? 7? And then we also have 4 is the Wi-Fi. It might be that I don't even have PCIe hot plugging turned on in this kernel, mind you. So PCI reset is a separate line, yes. There is like an internal reset thing. It's weird. Like there's one for the port and then one for the yeah. I think it depends on the implementation. Okay, so where is this? Device drivers, PCI support, PCI Express. Aha, there's no hot plug. And then PCI Express has port bus support. Aha, native hot plug, yes. That. Let's turn all of that on, actually. And there's switch controller. Oh, yeah, there you go. Looks, this is already, we already have that driver. Excellent. So that is upstream. That's cool. Okay, let's compile with that stuff. Is this going to do a full rebuild? I hate when it does that. Not sure. It doesn't look like a full rebuild. But it's rebuilding a bunch of crap. I'm doing it locally because my build machine is not running right now. It's a lot of rebuilding. I guess anything that touches PCIe is getting rebuilt. But at least not the whole kernel. Okay, there we go. So I'm going to just turn those GPIOs on first to see if it shows up without hot plug. Anyway, so we set 6, 7, and 4. And then we just do that. I'll use the Pro as a new dev machine or a studio. Actually, no, I'm probably going to use a laptop as a dev machine. The Mac Studio I have is my build machine. And the Pro, I am actually going to have a friend use because I honestly have no use for this. And like she's gonna, put it to much better use than I will. She uses macOS and all that. I mean, I still have it, access to it for testing and stuff. But since I have too many machines, sometimes I basically give them to friends as long as I can keep. like testing stuff on them, because there's no point in me hoarding like a zillion machines, and I usually only need them for that. XHCI, HC, is that PCI? I don't think so. Okay, let me boot and see what. Nope, still nothing. Okay, we will have to see what's up with that. Possibly the clock controls are not set, or that needs power stuff. Let me do a quick check for power stuff. Because there's this whole thing with the upstream port, and then USB-A is in here. Oh, look, there's a PCI reset also specified there. And then XHCI is, yeah, SATA. Yeah, there's a SATA controller also. And BIO is XHCI BIO, which I don't know why there's two XHCIs. Is that like the... How many ports? No, but like it only has 2 ports. Oh, maybe that's the internal one. PRSNT. I don't know what PRSNT is. Oh, present. That's probably an input. And then there's LAN and LAN B and Wi-Fi BT, which again has a PCI reset on that. I bet it needs. I bet the switch needs like some mode pins or something. And then the other thing is it was failing on some HPM stuff. Let's see, where is that? USB, where's the... We had some probe failure. No. Oh, there's some other stuff there. Interrupt map failed using interrupt controller. Yeah, we'll have to look at that. But hey, at least we got the switch showing up. So that's not bad. It might have been a fluke why those failed before. Maybe it's just something that's... I think all of them are probed, yeah. Yeah, 3, 3, 3, 3, 6, 9, yeah. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, they're all there. Okay. Okay. So yeah, we can see the switch. The driver doesn't attach to it. At least it's there. PMC Sierra Inc. device 4000. Yeah, that is what it's supposed to show up as. And it should be attaching to it. Oh yeah, no, okay, no, it's PCIe port. Maybe it's because there's like, I don't know. I think the management is supposed to be like a sub function or something. So yeah, this probably isn't booting, or it's missing some in it that we need to do, and probably has to do with the GPIOs, the mode stuff. All right, I need to get some dinner. Not bad though. We got the PCI host root port working, and we figured out that the Linux driver is made some bad design choices and only supports one root port right now. So we'll have to figure that out. Also, this is gonna be nice. So physical data 16. Let's see if it negotiated all 16 slots. That's actually hold on. Let's look at that because I'm curious whether it got the right link width. Link status. Yes, 16x, 16 gigatransfers per second. Where's the generation? Oh wait, no, I'm dumb. This PCIe, the first controller is supposed to be seeing the Radeon. The second one is supposed to be seeing all the USB and other crap. So the Radeon is supposed to be showing up on this one. I know macOS detected the Radeon. Is there another reset? Hold on. Because I know there's a bunch of port slots here, and they might have reset pins. Sorry, G0. Wait, why is G0... Why does that have SATA and other crap? I'm confused. The G0 has a 16X? But has LAN and stuff behind it? Hold on. That's why I thought it was the other way around, but... Yeah, but there's only present pins, though. Okay, that's weird. Because I would have expected the GPU to show up on the 16X root. But now that we know the 0 is 16X, that's kind of confusing now. But maybe it's just kind of backwards and... So about the present GPIOs, can I read them? They start at 37. 38. Aha, so one's present. And I think it's slot 1. 39, is it? No, 7F. Yeah. E6. Yeah. Yeah, okay, so that's my Radeon right there, the 1. So it's present. And there's also the switch management endpoint in there. Yeah, okay, so I don't know. I'm pretty sure there's going to be something we need to do here with... let's try... So BCI reset, just checking that. It's 52. Pin 9. Yeah, those are both 1, so it's unresetted. And clock req is 8 on that. Those are, yeah, set to the function, which is correct, I think. That one's supposed to be automatic. And there's an I2C link to the PCIe switch too, which we'll have to look at that. Okay, yeah, that's going to be enough for now. And yeah, the PCI is going to be really crazy with the newer generations. This is Gen 4, which isn't even as crazy. And this is in Die 1, which is not what I expected, but it's the same as the others. Okay. I'm just going to push that for now. What's the progress on microphone development? The mics work on some dev branch, I think, that Povec has, so hopefully we can get that integrated soon enough. Yes, it boots. It booted like a long time ago. Lena has to take care of the GPU, and I got the PCI Express switch to show up on one of the host controllers. The other host controller is dead because Linux driver only supports one. So I'll have to look at that next time and then see. There's probably some GPIOs we need to flip or I2C stuff we need to do to make the thing boot. So yeah, we'll have to see what's going on with that. Mic and speakers kind of come together, but may or may not. We'll see about that. Okay, I need to head out, get some dinner because I'm really, really, really hungry right now. And yes, it should be Gen 4 16X. So yeah, that's the story. Let me just push this. Wait, did I already pushed? And the Linux stuff is right now just device trees. So we're just gonna. I'm just gonna put this in the right branch. Yeah. Cherry pick that dot Asahi whip. So I have a 0 base on this. I don't know if I have a base on the 0. Maybe not. Whoops. I think that's just an unrelated thing. Yeah, parent 0. We're just dropping the mapper. And now what? Parent head, PDMA parent is MTP. PIODMA, and this is deleting PIODMA. Yeah, just a bunch of stupid merge conflicts. This has nothing to do with what I did today. It's just the others fixed up in the queue are Have anything else? Nope. Continue, and then that's also going to work again. Parent. Is that we just put on NTP and don't put on VIO DMA. Rebasing. Okay. And I'm not going to tag a kernel, but I'll push what I have so far in case anyone wants to mess with it. And it's time for dinner. All right, thank you everyone for showing up. How many people do we have? I think we have like 67 people. Okay, that's a lot. The peak was like 94. Okay, that's kind of crazy. So yeah, we got the bridge to show up. I get the feeling that and the ports work. I get the feeling that by just tracing the GPIOs and maybe the ASCII, we're going to find something interesting there that is going to tell us how to make it work. Either that or it's something in the bridge. I think it's just going to be some dumb GPIOs. There's all those mode pins that are really sus. So yeah, probably setting those to some combination before and hitting some reset pin or something will do what I want. So yeah, great. Thank you everyone for coming. And there you go. That's most of the Mac Pro bringup, and also the Mac Studio M2 Ultra is going to benefit from all those crazy device trees I had to deal with. Yeah, although we don't actually need the driver for the bridge. That's like a management endpoint, and I don't think we actually need to do much with that as long as we can get it to start up and talk to the devices. But also, I'm sure Apple has custom firmware for that thing, so who knows? Maybe the whole thing doesn't even work properly with the driver. But anyway, all right. See you next time. Bye.